Welcome to the demo of my R implementation of the Bradley-Terry model. First, let's load it in. We'll load in some data. Here we're going to look at the AFL seasons from 2010 to 2019. The data looks like this. We have the data matches played, who was at home and who was away, and what the scores were. We need to convert this into the win and loss matrices to fit our model. So we do this like so. We'll have a look at the win-loss table to see roughly who we think might be the best and the worst teams. And this is what the win matrix looks like. So for instance, this here represents that Port Adelaide beat Richmond at home twice in this data set. So first, we'll just fit the vanilla model without a home ground advantage. We'll have a look at the estimates for theta, seeing that Gold Coast came last, so they're the reference team. We set them to 0 to specify the model. See the standard errors? And because Gold Coast have been set to 0, they don't have an error. And we can have a look at a plot of what these look like on the right. As we see, it's roughly what we expect. Geelong, Hawthorn, Sydney were the best. Gold Coast, Brisbane, Melbourne were the worst. So now let's fit the team-specific home ground advantage. Each team gets their own alpha. We have a look at the thetas. Bit different, but similar enough. We have a look at the alpha values, mainly positive, though a couple teams do have negative values and a few that are close to 0. We can get errors for all of these. And we can plot this as well, where the red is just the theta, representing their skill away from home, and green is theta plus alpha, representing their skill at home. We can compare this model to the model with no home ground, like so. We'll see there's quite a bit of evidence to suggest that it is a better fit. However, if we compare it to the common home ground model, model 1, we see that there's actually not a lot of evidence to suggest that we should be using unique alphas for each and every team. Now, while there's no strict hierarchy like in the NBA, about half the teams in the AFL are Victorian, while the other half are not. So we'll create a hierarchy along these lines. We define these groups, and using the simple hierarchy function, we can create a nice hierarchy matrix like this. One shows that the teams are on opposite groups. So for instance, Port Adelaide are non-Victorian, but Richmond are Victorian. Richmond's a suburb in Melbourne. However, Port Adelaide and West Coast, a team based out of Perth, are both non-Victorian, so they get a 2. Similarly, Richmond and Western Bulldogs, a team based out of Footscray, Melbourne, also get a 2 as they're both Victorian. So we fit the mini hierarchical model now, or the common hierarchical model, and we'll have 2 alphas, one for level 1 and one for level 2. So as we can see, there's a higher level of home ground advantage when when a Victorian team hosts an interstate team or vice versa, than when a Victorian team's hosting a Victorian team or interstate hosting interstate. As to be expected, I suppose. We can get errors for all of these. We can compare it to the vanilla model and see that there's quite strong evidence, as expected. We can compare it to team-specific and see there's really no evidence at all that the team-specific would do a better job than the mini-hierarchical. And finally, if we compare it to the common, we can actually see that there's quite a bit of evidence to suggest a mini-hierarchical fit with these 2 alphas would do a much better job of describing the data than just the common home ground model would, which shows that there's some reason for us to bother implementing the hierarchical models. The package also has a few other nice things. We can get bootstrap errors. Usually this will do 100 runs to converge and will take quite a bit longer, but here we'll just do 5 to show what it looks like. And we get errors like this. We also have a predict function, which will tell you the probability under a certain model that the home team will defeat some specific away team, like so. And if we look over here, that's kind of to be expected. Sydney are the best, Brisbane are close to the bottom. We can also use the match sim function, which will simulate a match between these two and return who would win. If we do it 30 times, we'll see it's dominated by Sydney, but Brisbane will win a handful of matches. We can also simulate a whole season. If we look at that, it'll be the same matches as we specified in the data set. You'll see that the results have been simulated as with just a 1 and a 0 for who would win and who would lose. If you would like to see this, or if you'd like to download this script to run yourself, it's just under the talk function in the examples folder on the GitHub project.